Hello, welcome to another video in the NetWorker training series. In this video, we will be learning about data domain device on NetWorker. We will look at how to create and manage a DD device. So if you're already familiar with the Dell EMC data domain, then you should already know that the different protocols that the data domain supports. For those who are not familiar with the data domain or the DD, Dell EMC data domain, which I will be referring to as DD going forward, is a data protection storage solution from Dell EMC with deduplication and compression levels, which is the best in the market right now. Data domain has been recently rebranded by Dell as Power Protect DD, so let's try to call it that from now on. I am very much used to calling it just DD, so might slip up from now and then. So the Power Protect DD supports protocols like NFS, CIFS, and DDBoost, and it uses these protocols to be able to integrate with the different backup solutions it supports, of which DDBoost is the most efficient. So what exactly do we mean by deduplication? So data deduplication, often called as intelligent compression or single instance storage, is a process that eliminates a redundant copy of data and reduces storage overhead. Data deduplication techniques ensure that only one unique instance of data is retained on the storage media, such as disk, flash, or even tape. Redundant data blocks are replaced with a pointer to the unique data copy. In that way, data duplication closely aligns with incremental backup, which copies only the data that has changed since the last previous backup. There are two main types of deduplication that are seen on most of the deduplication related products. One is the file level deduplication. The file level data deduplication compares a file to be backed up or archived with copies that are already stored. This is done by checking its attribute against an index. If the file is unique, it is stored and the index is updated. If not, only a pointer to the existing file is stored. The result is that only one instance of the file is saved and subsequent copies are replaced with a pointer to the original file. The next type is the block level deduplication. So block level deduplication looks within a file and saves unique iteration of each block. All the blocks are broken into chunks which may be of fixed length or variable length. Each chunk of data is processed using an hash algorithm. This process generates a unique number for each piece, which is then stored in an index. So if a file is updated, only the changed data is saved. Even if only a few bytes of the documentation or presentation have changed, the changes don't constitute to an entire new file. This behavior makes block deduplication far more efficient. However, block deduplication needs more processing power and uses a much larger index to track the individual pieces. So data domain uses block level deduplication along with compression, which further reduces the actual data stored on the disk. The blocks are broken into smaller chunks with variable length, which further enhances the deduplication process and makes data domain the best product that we have for deduplication on the market right now. So what is data domain boost or DDBoost as it is commonly called? Data domain boost or DDBoost software provides advanced integration with backup and enterprise application for increased performance and ease of use. Data domain, when used with other protocols that it supports, is a target-based deduplication device, which means that the data is transferred as a whole to the data domain and the deduplication happens on its whole on the DD itself. But when using DDBoost, it distributes part of the deduplication process to the backup server or the application client, enabling client-side deduplication for faster, more efficient backup and recovery. DDBoost software is an optional product that requires a separate license to operate on the data domain system. You can purchase a DDBoost software license key for a data domain system directly from EMC. The networker integration with data domain is done using DDBoost deduplication device, and these are the integration features that are available to you. The first one, DDBoost and the data deduplication. So networker client software uses DDBoost components within itself to integrate with the DDBoost logical storage device on the data domain. This allows distributed segment processing, which helps the DD to process the data duplication inline rather than at the destination. Only unique data segments or chunks are sent over the network to the data domain, thus reducing the amount of data transferred and also reduces the duration of backup. DDBoost can run up to 120 concurrent sessions or save streams on each DDBoost device for backup and recovery. Data Domain Cloud Tier is a long-term data retention solution that enables the movement of data from an active tier to the cloud tier and then to an external cloud provider. Data Domain High Availability Support. When a high availability data domain system failovers to a standby high available data domain system, NMC displays event messages. All in progress network operations including backup, clone and recover operations are unaffected except for a temporary freeze of operation for a few minutes. However, during unusually long freezes, for example over 10 minutes, some network operations might fail but are automatically retried. Some failed network operations might require a manual restart as well. Client direct handling. This feature is enabled by default, and the option to enable or disable that is available on the properties of the client instance. The client direct feature enables clients that have a direct network connection to the data domain to send and receive data directly to the data domain. Client Direct supports multiple concurrent backup and restore operations that bypass the network storage node, which eliminates a potential bottleneck. The storage node manages the device that the client uses but does not handle the backup data. DDBoost Device Storage. A DDBoost domain system stores deduplicated networker backup on DDBoost storage devices on the data domain system. The networker server, storage node, and client direct clients can all access the DDBoost device. The DDBoost device appears as a folder that resides in a storage unit or SU partition. The next feature is about the synthetic full backup. So networker synthetic full backup feature is an efficient way to create full backups for combining an existing full and incremental backups. This feature integrates the networker synthetic full backup feature and the data domain virtual synthetic features. NetWorker creates the synthetic full backups directly on the data domain device. By default, both the networker software and the data domain system are configured to enable DDBoost synthetic full backups. Next feature is about the DDBoost in-flight encryption. This configuration is actually transparent to NetWorker and can be set up on the DD with DDoS version 5.5 or later. Alright, the next operation or the next feature that we can look at is the DDBoost clone operation. Now the clone operation in NetWorker is the process of creating a secondary copy of save set, usually to be stored at an offsite location. When the save set to be cloned is on a DDBoost device and the destination device where the clone is being done is also a DDBoost device, then the networker can make use of the clone controlled replication or CCR. This operation replicates data from a DDBoost device to another DDBoost device. This feature also uses deduplication. And sends only the unique data over the network to the target data domain, which results in less data sent over the network. The replication used on the data domain is of the type file level replication and is a feature of DDBoost on DD. In the next feature, you can use the networker management console to efficiently configure, monitor, and generate reports for DDBoost devices. The NMC server and the networker server must have network access to each managed data domain systems. The data domain retention lock feature within Network allows you to efficiently manage and store different types of data backed up by Networker to a single data domain system by securely locking the data on that system. This prevents accidental deletion of save sets. When you enable a device with DD retention lock, and DD retention lock period is a DD retention lock period is set in data protection policy action. The safe set backed up to the networker policy cannot be overwritten, modified, or deleted for the duration of the retention lock. This can be set up to a maximum of 70 years. Additionally, the device cannot be removed or labeled at any time during the retention period. Though the device that contains the retention lock safe set can be mounted and unmounted. The secure locking of data occurs at an individual file level, and locked files can coexist with unlocked files on the data domain system. Before we get into the do's and don'ts for a data domain device, let's take a look at the network requirements for creating a DDBoost device on NetWorker. So the DDBoost device does not distinguish between LAN and WAN connection as far as there is 0% packet loss and the latency is less than 20 milliseconds. It is recommended to use two separate IP network connections to the data domain device, one for administration and the other for data backup. There is a lot of helpful recommendations provided on the NetWorker data domain integration guide. I strongly suggest you to go through it. So there are a few do's and don'ts that you need to follow, which cannot be enforced, but it is best you know about it and make sure that are followed so that you have the highest level of deduplication and compression that can be got from your system. So the first is, do not encrypt the data that is to be backed up by the data domain. This has a huge impact on the deduplication performance as encryption creates more unique data blocks. If you are in need of encryption, keep in mind that data domain already supports encryption for data at rest as well as for data in flight. So make use of it. For more details, look at the data domain document. Do not use compressed data that needs to be backed up as well. This has the similar effect of encrypting data and usually results in very poor deduplication and compression ratios. Select only DDBoost device for the pools. Do not mix DDBoost devices with other types of storage devices. NetWorker does not limit the number of DDBoost devices that you can create. The number of required devices depends on the usage for backup operation and restore operation. Increasing the number of DDBoost devices can impact data domain performance and maintenance. Use target session and max session to allow concurrent backup sessions. Also, on the target session, set the field to a low level so that there are multiple NSR MMD spawned for the same device. Avoid deleting DDBoost device because the folder that is created on the data domain cannot be deleted in such a scenario. So whenever you are creating a new device, make sure that you have planned all the devices and make sure that you do create the devices with the correct information so that you don't have to delete it and leave the residue behind. So here we will be talking about the different operations that you can carry out on the data domain device. How you create a device, how you label it, mount it, unmount it, and reset it. So to create a DDBoost device, we need a folder inside the storage unit where we want the device to reside. So you cannot manually create a device that easily. It is not impossible for you to create this folder for the device, but it is a lot of hassle. However, you can create a device without the wizard when you are creating an already existing device. This might be for volume sharing. For more details on volume sharing, please refer the NetWorker and data domain integration guide. You can label the DDBoost device from the command prompt using the -L switch. So let's now look at how to manage a data domain device. So you can create a DDBoost device using the device creation wizard on the NMC. You can also create it manually, but it is a lot of hassle because there needs to be a folder that already should be existing within the storage unit for a device to be created. A DDBoost creation or DDBoost device creation wizard takes care of creating this folder automatically for you, so it's a lot easier for you to use the uh, device creation wizard than going to create the device manually. To label mount unmount, you can always use the NMC, but if in case you want to use the command prompt for this, you can use the nsr nmm command. If you have already seen the video for managing standalone tape device, it is similar for the data domain as well, where we use the nsr mm command. To label a device, we use the nsr mm-l command. You can mention the name of the pool as well here, but by default a data domain is already assigned to a pool, so by using this it gets automatically labeled to the respective pool. The next command on your screen is for mounting a device, a DD device, and this particular command uses the -m switch to do this. The -u switch is used to unmount the device, and if in case you need to do a soft reset on the device itself, it can be done using -h switch. So this was all about the device itself. Now let's go ahead and check a quick demo on how to carry out all these operations on NetWorker. Alright, so for the demo, we will be starting with configuring the data domain with the DDBoost protocol so that you know how to work on this from scratch. Then we are going to create an additional M3 that we can use to create the non-default device on, because by default the device on the that we create on the NetWorker is created under the storage unit with the same name as the host name of the backup server. And then we are going to carry out the different operations on that system. So let's get going. Let's first log into the management console with sysadmin or any other user that you have created which has management rights. So you see that under the M3 we already have 3 M3s here. 2 M3s, sorry. This is the one which is by default, and this is the one that we had created for our AFTD lesson. So let's go ahead and look at the protocols. So we are interested in the DDBoost protocol, and as you see, it is not yet disabled. Before you enable this, go ahead and check if you have the licenses required. So right now I'm running the trial version of data domain, so I have all these features enabled as part of the trial license, and also I am supported with a capacity of 500 MB of protected data. So let's go back to protocol and enable the DDBoost. So the DDBoost is enabled, and you will see that the client that are allowed is currently star, which is usually a good practice because you want all the clients in your environment to talk to the data domain. But if you have security concerns related to this, you can go ahead and add individual clients that are allowed to directly talk to the data domain to this list. To add it, just have to click on the plus icon here, then give it the name of the client, what authentication mode they are using, and then the encryption strength as well. So click on cancel there. Next, we will have to create a DDBoost user. So this particular user will be used whenever you are creating a device on the data domain. Well, let's go ahead and do that first. So we don't have a new existing user, so we're going to create a new user. Let's call this user boost_user. and I'll give it a password boost123, boost123, and we say add. Oh, it's a weak password, it says, so let's go ahead and change the password, create again, create local admin, let's say boost underscore user, we'll give it a stronger password, and then say add. Excellent. With this done, we can go over to the NMC. And as you saw, one of the features that was available with the data domain and network integration is the use of NMC to manage or monitor the data domain. So before we go ahead and do that, let's pull up the name that I'm going to cat the etc hosts. Okay, the server that we are using is DDVE, so that's copied. Let's go back to our NMC, right click anywhere, and when you're updated the or clicked on the devices tab, say new device wizard. We'll be selecting the data domain device, the device type as data domain, then click on next, next again. Here it is it's asking me to add the data domain device. So if this was the second device that you were creating and the data domain was already added, then the option above this should have been used. But right now we do not have any DDs configured, so let's put that here. Let's put the boost user credentials here. Next, the DD management credentials. We need to mention this specifically for the virtual machine, FLR, and instance access backup. So if you are using VM backups using vProxy, then it would be a good practice to put a management credentials here. The management credential I have is sysadmin, so you can mention that here. And then we are going to click on next with the rest of the configuration as it is. So if my password is correct, if the host name is resolving properly into an IP address, I can go to the next page wherein I have to create the folder. So this folder is created inside the storage unit for the data domain, and I can give this a name, boost underscore device 1. Let's call it this and select it. It's going to show you here that you have selected this as the storage path, and the name of the device is going to be this. You can give any suitable name. Pool name can be part of the device so that you know that which device belongs to which pool, or it can be depending on what type of backup you're doing, so on and so forth. Again, depends on how you're segregating your data. So click on next. The next is to select the backup pools, or the backup clone pool. So if you remember how we did the created the AFTD using the wizard, there we did not have an option to create a new pool, but for DDV you do have an option to create a new pool, and that comes in very handy when your pool is not yet created. So even for this option, I'm going to create a new pool. Let's call it backup, DDV backup, and this is going to be a backup type, and I want to label and mount the device after it is created. Click on next. Now the storage node, I'm going to use the backup server itself as a storage node, but you have an option to either use the other two storage nodes that we have. So let that be as it is. So we already spoke about retention lock. So in case you want to enable retention lock, you can enable that, and you can mention if it is a compliance lock or a governance lock, but I'm not going to select that for now. Click on next. So this is to integrate your data domain with the NMC. It is going to be integrated with, you are using SNMP. I'm just going to mention this as public, but I have nothing set up on the data domain for SNMP. So let's leave it here for now. Get back to it later. And then click on next. This is the summary. If you look at the summary, you will see that the first operation is to create a new storage unit called LNW1, and a folder is created within that. Next is to create the data domain device itself and on that location using the boost credentials that we had provided. Create a label template, create a pool, create once that is done, then you can label that particular device that was created on step number 3 or 2. And once that is done, the operation for device creation and labeling is complete. But since this data domain is being added for the first time, it is also configuring the host to be added to the NMC. So you see that data domain is going to be monitored for these particular traps. As I said, this is going to be an SNMP integration with the data domain, the name of the string, and also the management credentials. Let's go ahead and click on configure and wait for a few minutes, a few seconds rather. So the first volume creation might be a little longer than usual because it has to do a lot of other things as well. So you see in the summary here that all the operations that was listed are completed successfully. Now if I click on finish and see that the device is created, here, this one. Let's quickly check on the properties. So device properties, and you will see that the access information is indeed the target data domain, the storage unit name, which was created automatically, which I'm going to show you in a few minutes, and the folder within that particular storage unit. It already has a remote user and password updated, which is the DDBoost user, and that's about. Okay, let's now go ahead and check on the data domain as to what changes have occurred there. So if I go to storage units, I will now see that there is a new storage unit created with the host name of the backup server, LNW1. The user is this particular boost user, and the rest of the details. So if I show you the M tree as well, so this is the new M tree, which is in turn the storage unit which was created during this operation. So now what we can try and do is, let's create a device on an existing M tree. Let's see how to do that. All right, let's go back. Okay, right click, same process, new device wizard, data domain, next, so put in the DDBoost credentials, that is boost_user and the password. This time, instead of just going ahead, I'm going to select configure secure multi-tenancy, and then we are going to use an existing secure storage unit or create a new one. So let's create a new storage unit. We cannot use the existing M tree because it is not added as a storage unit. So let's say we want to create a separate M tree or a storage unit for customer A, assuming that the backup environment that we have is a leverage or multi-customer supporting environment, and then select next. Again the same process, customer1_device1, and then we select this, review the device name, change it if you want to, click on next, pool, let's take another pool. We are assuming we are isolating the data, right? And then create next again. For the storage unit, for the storage node, I'm going to use our Windows storage node. And then select next. This is already configured, so nothing needs to be done there. Next again. This is the summary, so we are going to add yet another new storage unit. We're going to create the device, create the label template, create the pool, label the template, and modify the SNMP. Click on configure. All right, done. And this is the new one. Let's arrange it by media type. And this is the one for the Windows host. This is all about creating a device. So labeling a device is pretty simple. Like we have already seen, we just have to right click on the device and say label. Relabeling is hardly any time required for a data domain device, because the data domain device purges data every day and removes all the recyclable save sets on it automatically. Do not have to intervene. So all you'll have to make sure is that the data domain does not reach 100%. There is another property on NetWorker 9.x and above that I wanted to discuss about. There is an additional option on NetWorker which monitors the availability of device on the DD. When the networker senses that a device is not accessible, whatever cause it may be, it will mark the device as a suspect and will not allow the backup to use this device. So let's take a look at that option. It's obvious we have to enable diagnostic mode. Let's go to properties again and look at configuration. And you see this particular option here, which is operations, device connectivity check. So this is a good feature as it allows you to know if your DD has an issue or if it is down. But there is one drawback from this option, which is that the check runs every few minutes and creates a read stream to the DD. And in case you have a lot of devices configured on a single data domain, it might contribute to the total sessions available to the DD. This has been seen to cause problems in some environment, depriving the recovery, backup, or clone operation of available save sets to the data domain. For example, on PowerProtect DD6300, the base configuration has a stream count of 270 writes and 75 reads. So if you have, for example, 60 to 75, 60, 70, or maybe 50 or more devices create on that system, that means that there are 50 streams of read associated with that particular data domain, and that in turn reduces the total available streams to just maybe 15 or 25, depending on how many devices that you have. So this can be disabled on the NMC as on NetWorker 19.2, but in case of a previous version, this has to be done using the NSR admin. So now let's run a backup to these devices, and let's see how we can determine if we are running a client direct or not. So what I can do is quickly jump back. I'll be back after setting this up. Alright, so I have set everything up and I'm going to go ahead and start the backup and say yes. We'll wait for a few minutes for the streams to start. So the backup is almost starting now. Let's go ahead and see if the stream is already created. On the data domain, where we can go to protocols, DDBoost, and then click on active connection. And here you're going to see that the Windows host is currently connected to it. So the status idle means that it is connected to it actively. I think it is clearer if I can show it to you here. Let's SSH into the DDBE. Yes. And if I show you the DDBoost, let's see, okay, connections and active. Connection should be enough. Okay, the page is not enough. Let me run it again. Okay, so here you see that the Windows server is having a connection right now and the idle is no, which means that the connection is currently active. So this is one of the ways you can make sure that your client is directly connected to the data domain and sending information directly to the data domain. So these are some of the things that I had regarding the DDBoost device. There are many more things that you can understand and learn about, and you can refer the admin guide for this. Thanks for sticking with me till the end of this video. I hope you found this useful. If you have any questions or comments, share it with our community in the comment section below, or you can drop me a message at my Twitter account. I will see you on another video. Goodbye.